It's short and sweet because people can't follow it for long, long lectures, essays,
Yeah.
so they say.
Right. So we're just trying to keep people engaged as much as possible.
The model that we came up with is that it's like, university science coffee. Everybody brings their coffee cup and everybody starts talking, but in this case, it's a guided discussion. But it's really, because when you go to science coffee, unless somebody's in a rant, everybody kind of talks quickly. Oh, what about this? Da, 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 da. So it's that kind of interaction we're trying to capture.
Yeah. Okay. All right. Well, it's time. I'm going to go ahead and start, and we'll get going. You guys ready?
Ready.
All right. Here goes. Oh, shoot. I forgot to. Oh, never mind. Hello, everybody, and welcome back to this week's Astro Coffee Hangout. My name is Tony Darnell, and I'm from deepastronomy.com, and we are happy you're joining us for what we're hoping will be a more bigger thing as time goes on. People get more jazzed about these Astro Coffees because we want to give you a glimpse into some of the workings of what it's like to be an astronomer, because in institutes and universities around the world, at some place or another, they're taking time out of every week to kind of discuss the latest interesting work that their colleagues have been doing in astronomy, and we want to bring that sense of discovery to you guys. We want to kind of bring that, make it available to you so you guys can ask professional astronomers about some of the latest cutting-edge research in the field of astronomy. And today we've got a really great topic. We're going to be talking with members of the NASA's New Horizons mission team about, of course, Pluto, everybody's favorite minor planet, and some people's who can't let go. They're still their favorite planet, but it is a minor planet now. We're going to talk about some of the latest results as NASA has flown by. And joining me on these Hangouts every single week is my good friend and colleague, Dr. Carol Christian. Hi, Carol. You are muted, just so you know. Oh, you unmuted yourself? No, you didn't.
Yes,
Hi, Carol.
I did.
Welcome.
Hi, how are you? And don't forget to acknowledge our sponsors, the
I
American
certainly will.
Astronomical
That's next.
Society and the American Astronautical Society. Thank you very much for your support.
That's right. These Hangouts are endorsed, not necessarily sponsored by these guys, but they do endorse what we're talking about because it helps bring their memberships, the scientists and astronomers that are members of these organizations, their latest work to you, and they're providing it as a service and a resource to their membership. Now, while this Hangout is endorsed by both of those organizations, the views and opinions expressed in this Hangout are not necessarily endorsed by these organizations. So I needed to clarify that.
Especially maybe mine.
That's right. Especially anything Carol says. They do not endorse anything she says. So anyway, I want to welcome you guys. And because this is a Hangout and because we want you guys to get involved, we want you guys to ask us questions. There's two big ways you can do it. One of them is if you go to the website, deepastronomy.com/live. I have a live chat client set up, and George Caldwell's already there, as well as Patrick Waters and a few other people, TR54, joining in. And that is the best way you can interact with us, because I'm looking right at this chat right now. Another thing I have up on my tweet deck is Twitter, using the hashtag AstroCoffee. I couldn't get it to fit on my lower third, so you don't see it there, but it's hashtag AstroCoffee. I'm looking at that right now, so you can also ask us questions and leave comments for our guests in those two ways. So thank you very much. And so let me go ahead and get started. We have members of the New Horizons team with us. All of these guys are from the Southwest Research Institute. I'll start with Dr. John Spencer. He is he's the deputy project scientist. Let me click on him so he stays up. And he's a deputy project scientist at Southwest. Hi, John. Welcome.
Hi. Happy to be here.
Good. Thank you. I'm glad you could join us. Also joining me are two other members, also from the Southwest Research Institute. Is Kelsey Singer. She is a postdoc. Hi, Kelsey.
Hello. Hello.
And also joining me is Amanda Zangari. She's also a postdoc, also a member of the team. Now, let me ask you guys hi, Amanda. So let me ask you guys before I get too much further, what is the Southwest Research Institute? Well, I hear about this all the time, but John, can you tell us just what, you're not NASA, right? But you do a lot of work with New Horizons and stuff. Give us what is that? What does Southwest do? Southwest Research Institute.
Oh, yeah, sure. It's an organization headquartered in San Antonio. They have a big campus down there, and they do all kinds of research work for government and industry that involves nuclear power, energy efficiency, the oil industry, geology, and space science. And so we're part of the space science part of that operation. And a lot of us are up here in beautiful Boulder, Colorado, but we're part of our head office is still down in San Antonio. Right.
So I guess it's kind of like JPL, isn't it? I mean, JPL isn't really NASA, but it does a lot of NASA things. Is it kind of like that, or is it more of a research place, more of a science place?
It's a little more independent from NASA than JPL is, but a lot of our work, most of our work, in fact, is funded by NASA through various grants and contracts. And so NASA is ultimately our paymaster.
Okay, and you are the deputy project scientist, right? Give us a little sense of what you're doing with New Horizons.
Sure. Right now, we're wrapping up the New Horizons Pluto encounter. We just got the last of the data down from the New Horizons, from the Pluto flyby, and that's a great milestone that we're happy to have reached.
Hooray!
Hey,
Yeah.
so you do. You actually have all the data on disk
Every
here.
single bit is now
It's on Earth.
on the
Okay,
ground, all
wonderful.
safely down. But we're now looking forward to the next phase of the mission, and that's particularly what I'm involved in. In a couple of years, we're going to be flying past the Kuiper Belt object, this small primordial object, 1 billion miles beyond Pluto. We'll be flying within a few thousand kilometers of this kind of object that's like no object we've ever been to before, and we're very excited to see what those objects are like. But we have a great deal of work to do in the 2 years before we get there to plan exactly what the spacecraft will do when it gets there, and all the things it's going to do along the way.
Yeah, I want to get to that.
So I'm up to here in that at the moment.
Yeah, okay. I want to get to that part of the mission in just a little bit, but let me get Kelsey and Amanda involved here. Kelsey, give us a little sense of what you're doing with the project and what your role is, what you're working on.
Sure. So before we got to Pluto, I was helping with some of the observation planning. Of course, we had to have everything planned in advance because we were flying by so quickly. And then I have since been working on the wonderful and amazing surface features that we found on Pluto and Charon. So that's my main role at the moment.
Okay. And Amanda, how about what you're doing?
So I've done a lot of different things. Some things that I've been doing have been related to just where things are on Pluto, because a lot of previous observations from the ground, Pluto was just a point of light in the best Hubble Space Telescope observation. So it was really easy for people to stick it the wrong way up. So that's one of the things I worked on, which was a very much behind the scenes thing. Other things I'm helping.
What are you talking about? Object identification, the surface feature identification, things like that?
Yeah.
Okay.
Making sure that you know where the old observations correspond to, Pluto. Now that we can see Pluto, the surface it's very obvious what things are where. It's got Tombaugh Regio, it's got Cthulhu Regio. It's got very distinct surface features. You're not gonna.
Actually, you could put up one of the slides.
Oh well,
for that
hang on. Hang on. I got just what I'm going to do, because these are some images that Kelsey had sent us. So let me just start right here. This is something Carol can actually speak to a little bit, I believe. But before New Horizons got to Pluto, this is what we could see. And as you can tell, I mean, what is this, Carol? Can you give us a little background on this image? Are you there? Carol?
I'm here. I'm
Okay.
back. I'm back.
I think
my mouse doesn't work very quickly. It's like a delay, so it'll take me a minute to unmute.
okay.
So many telescopes. People have observed Pluto with many telescopes, but of course, there have been programs to look at Pluto with HST. And Mark Bowie and his team, long time, have used HST to understand what might the surface look like. And so they have tried to do mapping. And so by the variation of light reflected from the sun, they provided maps, and then that was put on a sphere to guess what kind of features might be there. And of course, I remember the first observation, we were like, we don't know. But then after several observations, they continued on, and it looked like some of the features were indeed persistent. And I don't think anybody expected Pluto to have at least a thick atmosphere. So it was surmised that the brightening and darkening must be due to some kind of surface features. And so I have to say, from the Hubble standpoint, it was really nice to know that, well, actually that was true. But of course, that there's nothing like going there, you know, and actually seeing it. But from our vantage point from Earth, this is what it looked like, and some of these features were persistent.
That's right, folks. So before New Horizons hit, the best telescope we had available, the Hubble Space Telescope, looked at it, and this was the best it could do. And now here comes slide number 9, Kelsey. Okay.
Yay!
Here you go. There you go.
Yeah, okay.
Okay, Kelsey, you want to comment on this one a little bit?
Sure. Yeah, so as Amanda was saying,
And Amanda, too. I'll have Amanda's comments on as well.
Yeah, we have informal names for some of the really distinctive surface features on Pluto. And the bright heart-shaped feature has been named after the discoverer. So that's whole
this
bright
right here,
heart.
right?
Yep, the whole bright heart is Tombaugh Reggio. And then the left side, which you can see is very different from the right side, that's been informally named Sputnik Planitia. And then this big dark equatorial band that Amanda mentioned has been informally named Cthulhu.
This part here.
Yep.
So Amanda, your job then was to go through and look at these features and decide which were distinct, or what? Give us a little more detail.
No, just that if you look at the previous slide, there's, you know, and versus this one, you can see that, oh, you know, I know that there's this heart-shaped thing, and that is, say, at 180 degrees longitude. And so it was more of saying, well, okay, this is where we've decided 180 degrees longitude is. Now, where is that back in our other images? And people had different reference frames for doing that. And so I was trying to make sure that they were all on the same page.
Awesome.
And we knew going back that this observation, you know, was taken of the Sputnik Planitia and Cthulhu Macula area versus some other place, because it was, when you don't have something as unique and distinctive, it's very easy to get that sort of thing wrong.
Yeah, Pluto is very confusing because its spin axis is tilted almost 90 degrees to the plane of the solar system, which means you have to figure out what to call north and what to call south.
Slide 3.
Yeah, and there have been different definitions for whether to use east longitude or west longitude and what the heck east and west means. So Amanda,
wait a minute, you said it was 90 degrees. Hang on, you said it was 90 degrees to the plane of the ecliptic. Is that what you said?
About 120. Check out slide 3.
Oh,
yes.
Oh, okay.
Yeah.
Then.
Amanda's the expert. She can explain.
All right.
They're ready.
Yeah,
You are. Good. Yes. There we go. All right.
It was actually pointed like this. So this is where the yellow North Pole is actually sticking around here somewhere.
Do you have your globe there in the office?
There you are. Okay, I've got it up now. So okay, I see what you're saying. So here we've got Pluto rotating in this way. Yeah, I see what you mean about east and west being very confusing. It's a lot like Uranus here, where Uranus is doing this kind of thing. So east and west is it up here or is it down there?
Right,
So,
and when there's nothing very distinctive to sort of anger people, it makes it a lot harder, especially with the Hubble Space Telescope pictures. So, you know, now it's way easier because you look at Pluto and you say, oh, hey, there's the heart. This is the side we saw. This is the side we didn't see. You know, there's the encounter hemisphere, and then there's the opposite hemisphere.
So what are you doing? So what is it east and west on these on Pluto then?
So we define east and west using the right hand rule. So if you take your right hand, this is my right hand, I don't know if it's reversed in the video, and you curl it around your fingers like you might do it in a physics class. This is the way, whichever way rotates this way. So Pluto, it would be like this. This is the North Pole, and this is the direction of rotation, and longitude increases in the direction of rotation. And we generally call this east longitude on the Earth. So on the Earth, we're tilted about 23 degrees, and we rotate like this. And so
Okay.
Pluto is tilted 120 degrees and rotates like this. And so on Earth, we used east longitude, and on the moon, we used east longitude. But the other major planets all use actually west longitude. And they don't define longitude using the right-hand rule. They have it is whatever is pointing north of the ecliptic.
Well, that's
basically,
good. I didn't
is
want it to be
north.
too consistent. I'm glad to hear that. I'm glad we're
And
doing
so, and the longitude is backwards. And so Pluto also used to follow that rule when it was considered a major planet. And so the other pole was considered north and longitude was considered to be going the other way. And so because both things were consistently used, people were using two types of things at the same time. And a lot of people didn't know which one they were talking about when previous surface features were given. And so if you want to go back and say, okay, did Pluto's surface change? You need to know where people were actually looking.
So how would you settle
Wait a
it?
minute.
Was it a big arm wrestling match, or?
Is that, yeah, that's what I want to know. It's like when you have the planetary meetings, are these big arguments about the latitude and longitude for each
So how do you win these arguments?
Are
Is
there,
it-
like different people who, like Amy Simon, which she wants
So ultimately-
Jupiter, so she only wants it to be this way. So,
Pretty
So
much.
the IAU actually makes the rules on this. And so the IAU said, this
International
pole should be in the
Astronomical
north
Union.
one. But then
Oh, boy.
when they changed, and it's a separate group from the Pluto's Not a Planet part of the IAU.
yeah, right.
But when they changed, they were like, hey, we can do whatever we want. And we noticed that all of you have been really trying hard to have this be the North Pole anyway. And we know you like it better because you're physicists. And that's what you learned in your physics
Oh,
classes.
tell me about it,
So
Amanda.
we're going to make it be the way you want now.
Watching
And-
you do
Yay.
that, I
Well,
had a
then,
big flashback of being in
mission-
physics class and taking a course, and we're all sitting here huddling in our exams, and I remember everybody, you could see everybody doing their right hand stuff, and they're like curling, and yeah,
Yep.
you gave me a lot of it was a big physics flashback right there.
That's exactly
Thank you for that.
And then it was funny because the mission was started launched in 2006, and you have to be very, very careful. And so it was launched before the decision was made. And so everything was using this pole because if you're a scientist writing your paper, you can do whatever you want, even though you really shouldn't. But if you're the mission, you have to do what's official. And so the mission had the other way. And so we had to switch to what we kind of really wanted to do, but we didn't want to mess anything up at the same time.
Well, good. Okay. Well, so we've during the flyby, we all got to take part in watching that happen, the excitement of all of that, and now John tells us that you now have all of the data that came from that flyby, which was fast, wasn't it, John? Give us a sense of how fast that flyby was, just real quick. Give us a little review. That thing did not take a long time.
The actual flyby itself, you mean?
Yeah, that was like just
Yeah.
a few hours. It was just a few hours,
Right, yeah. Yes. Our closest approach to Pluto was 12,000 kilometers, about 8,000 miles. And we were within 20,000 kilometers for an hour or so, something like that. So really, the spacecraft was very, very busy for a few hours, just cramming all the information onto the data recorders in that very precious time when we were at our closest. And so it was hours to take and then a year to downlink because we designed the spacecraft so it could take data very fast, but that was higher priority than getting the data down fast. We were prepared to be patient to get it all down. And
was there ever any worry? I mean, you've got it, you've taken the images, you're pretty sure you've got them on a local drive somewhere off on the spacecraft. Was anybody really worried about getting it back? I mean, was there any glitches in the internet connection between here and Pluto? Or does anybody?
There are definite glitches. Our internet connection is the Deep Space Network, these giant radio telescopes that are spread around the world. There's one in California, one in Australia, one in Spain, which are distributed so where no matter how the Earth turns, there's always one of them pointing at wherever you want to point in the sky. And yeah, sometimes one is down for maintenance or has a glitch or there's bad weather or something, and so we lose some data, but it's all still on the spacecraft. So we can request it to be played back later. So there was a lot of checking and monitoring and making sure everything was there. And pretty soon we'll be ready to, thank you, Amanda. If you look at Amanda's picture, you'll see a nice graphic of the Deep Space Network. A couple of the dishes there, or one of the dishes from 2 angles. So now we're going to do a review, make sure we're absolutely sure we have every bit before we erase anything on the spacecraft.
Is where I would be sitting in that picture.
Yeah.
Okay.
And you can see we're very high tech. I have my computer on a box there.
Ergonomics are important.
I just noticed that right here. Yeah.
Mm-hmm.
But this is where we were working, so we could all be together for the encounter, because you can work a lot faster if you have, you know, everyone in the same room, basically, looking at all these pictures for the first time, which is fun.
Okay.
And I have a quiz question for, I guess, you and Carol, because other people already know on this Hangout already know the answer, and maybe for the audience members. But do you know who the gentleman on the left with the big hair is?
He looks familiar, but I don't know his name. I'm sure Carol does. I don't.
He reminds me of Brian May.
That would be Brian May. So you win.
That's who I thought it was.
Yes, he also has a PhD. Took him a little while to get it because he was a little bit busy. Yeah, he was very interested in 3D imagery, and he has stuff on his own website about that. And he also knows the head of our mission, Alan Stern, and so he was invited to come out and hang with us. And as you can tell, he's very impressed with whatever I'm saying. But he's also... Yes, he's a very nice guy.
Yeah.
I was showing him actually some of our first topography and 3D that we got from the surface of Charon, Pluto's moon, and he's, as I said, very interested in this topic.
Okay, well, good. I want to bring that up real quick because that was your first slide. I want to show this because it's really cool to give people a sense of what we're talking about here. The relative sizes of all of these things. So here's what we're talking about, folks. We've got here's a nice slide that someone's put together, presumably Kelsey, that where you've got the Earth as compared to Pluto, which is much smaller, and this is Pluto's moon Charon, which is really close in size. It's not that different. You want to comment on this, anyone?
So they're a lot in real life. They're a lot further away.
Yeah, we're only talking about sizes here, folks.
About 1.5 Earths away from each other. But they're so close together that instead of a back to physics class orbiting everything orbits a mutual center of mass. Okay, but because Charon is so big relative to Pluto, the center of mass of the system is actually a couple hundred or so kilometers above Pluto's surface. We call it the barycenter, and so they rotate sort of like this instead of just one thing going around. Though actually, stars, for example, you're rotating around a center of mass, and so the stars actually wiggle because of their planets, and that's how extrasolar planets are found using the radial velocity measure. Is actually measuring that reflexive wiggle. But Pluto wiggles so much, it actually moves. It wiggles around something outside of the body.
Yep, we've talked about that many times. So yeah, there's kind of a wobble or a rotation around a common center that isn't the center of either one of these bodies, but somewhere else in between. So, okay, I want to start showing some pictures, Kelsey and Amanda and John. Tell me what I should put up. I want to show some cool pictures of Pluto. I've already shown this one.
I like 11.
I've already shown this one.
I was just going to say 11 as well. It gives us an idea of some of the other
there it is.
Interesting materials that are out in the outer solar system.
Okay, so here's what we talked about before with Cthulhu, and I want to talk about what that is in a minute, but let's go ahead and do this one. This is what you want to talk about. So what are we looking at? I'm going to let
Amanda go first.
Okay, go ahead, Amanda.
So these images were made with LISA, which is part of the Ralph instrument. It has two parts, and it scans over the surface in the infrared, and from that we can see the signature of different types of molecules on Pluto's surface. And these are the three big things that we saw that we were actually expecting to see. Carbon monoxide, which is mostly concentrated in Sputnik Planitia. Nitrogen, you also see that in Sputnik Planitia, and you also see methane. And so one of the scientific things we did was, we wanted to see what is Pluto made of. And the interesting thing about all of these elements is that none of them are on Charon.
Really? So let me just back up and let me just clarify some of the things you've just said. So this is Pluto as it appears with a filter that shows a lot of carbon monoxide. This one is molecular nitrogen. And
Yep.
this one is CH4. What is that? That's
Methane.
methane. Thank you. And so these are the brightnesses of each of these images show the abundances in those filters of these different things. And this little heart-shaped thing looks to be prominent in all of these, all three of these.
Yeah, there's a lot of theories about how it was formed. One of them is it's actually Pluto's polar cap. That because Pluto is tilted, the polar cap is on the equator, which actually receives less sunlight than the polar regions.
So this thing is rotating. You can't really see it.
You know,
I guess.
it's you know all these pictures. It was a decision made by the mission
to rotate them
in the around sometime around approach that every image we're going to just rotate it so the North Pole, which is again it's pointing down here, is facing up.
Okay, all right, that's good clarification. Thanks
yeah,
for that.
so this is there's a little grid on the methane picture, though, of CH4 all the way to the right. That is where the pole in the axis of rotation is, but it's sort of tilted. Here. And it turns out that if you're tilted like that, the poles actually receive more light than the equator, which is crazy. And so people, I think it was Doug Hamilton, was making a model that showed that this is actually one of the coldest places in the system, and it's functioning as a polar cap. And so that's why you see stuff condensing there.
Okay. All right. Anything else you want me to show, guys? Another cool picture.
I'll add a little bit to that while we're on this picture.
Oh, all right. Go ahead.
That's one theory for why this spot is here. Another theory is that there was a giant collision of something with Pluto that dug a big hole right there where Sputnik Planitia is now. And that deep hole then became the place where the atmosphere was the densest, just because the pressure is denser the lower down you go, just as it is on the Earth. And so that's where the atmosphere started condensing out. And so you just accumulated a lot of frost in that hole, and that filled it up with the nitrogen and the methane and the carbon monoxide that we see now. So we're still working on exactly how it is, but that's also a plausible explanation.
Great. Okay. So the what I want to show me what there's a couple of other features. This is not. Is this the other side of Pluto? What is this?
No, that's Charon.
Oh, that's Charon. Okay. Sorry.
Yeah, that's Charon. It's completely different. Like I said, it doesn't have it has no nitrogen, no carbon monoxide, and no methane, as seen by Lisa. What it's made of is actually mostly water, which at these temperatures are rock hard. And there is water on Pluto, and we weren't able to show that because it was being drowned out by the other things that I mentioned. But there's water, so if you have the heart, and this is Sputnik Planitia in the heart, there's a bunch of water here, and then there's a lot of water in Cthulhu in the dark places on Pluto.
Actually, I do have that on slide 34.
We do. There's
but
slide 34.
I don't know if we want to quite go there yet or not.
Yeah.
Well, I can go there anyway. There
Okay.
it is.
Oh, yes.
Okay. So these are the ice water concentrations. Go ahead.
And so, yeah, the places where the methane, the carbon monoxide, and the nitrogen isn't, you do start seeing a bunch of water.
Okay. So again, yeah, and we're seeing a big dearth. So this kind of goes into what you were talking about, John, with maybe something hitting it or something that sort of causes a lot of a big absence of what looks to me of water here, right?
Yeah,
so.
I think the big absence would be, regardless of what formed this hole, it's simply because that hole is now full of nitrogen. And so we know it's a big hole because we have the 3D topographic information. And yeah, that hole just filled up with nitrogen that's buried the water that was probably down there at the bottom of the hole.
Okay. And go ahead.
The nitrogen and the methane, they're going to flatten themselves out because the freezing point of both of those things is really, really low. Where water, the freezing point, as we all know, it's 0 degrees centigrade, 273 Kelvin, or 32 degrees Fahrenheit, take your pick. Pluto is much, 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 much colder than that. And so ice is rock hard. And so when we saw the topography, we said, well, there's got to be ice there because the nitrogen wouldn't hold itself up, but ice does at these temperatures.
Okay, well, Galaxy is asking a question, I think, about the other slide I had up with. She's asking, why are the nitrogen lines so straight? I think it's this. Yeah, here we go. She's asking, how come the N2 stripes are so straight? I think she's talking about these here.
Yeah, that is, so the diagonal striping in this image.
Yes.
Yeah, that is simply because this is a fairly early product that we put out, and it's the instrument calibration. We were still improving it at that point. So the instrument was scanning from the upper left to the lower right.
Okay, so those are instrument
So
artifacts then.
those are instrument artifacts that we're
Okay.
in the process of cleaning up, and we've now reduced them quite a bit. Not quite got rid of them, but they're not as obvious as they were then. So
All right, well, good
Yeah.
catch, Galaxia. I guess you're going to be a data processor coming up here on these too. That's pretty good. So, and Wout Vanderhout, hi Wout, I'm glad you're back, by the way. I haven't seen you in a while. He goes, do you have an image showing Charon's composition, what Charon is composed of? And I believe, did that one show it? This one? No, that was just...
Unfortunately, yeah, so I didn't put in a specific composition slide, but as you can see, there's a little bit of different stuff going on Pluto, or sorry, on Charon. And Amanda just said that mostly the surface composition that we see is water ice. I didn't put a slide in here, but if you go to the New Horizons website, it's a JHU APL website. There's a cool picture of one of the small craters that's kind of up in the northwest. You can see there's some little bright patches that are kind of in the northern area. And these are craters that have kicked out ejecta, and that ejecta is slightly different color, and in a few cases, a very slight different composition. And we see actually ammonia there. And so you can see a nice picture of that on the New Horizons website. But mostly we see water ice, as Amanda was saying. And then you can also tell that Charon has red hair. It has a red polar cap.
I love the name, by the way.
Yeah, which is kind of an unusual feature, and it's been informally named Mordor macula. So it's dark, and it's also red. And so that red is showing that we have a little processing of some of the materials that's on the surface of Charon. And so
but you're not sure what it is. Is that true? Or?
We actually think it's it is actually thought to be some methane that was trapped in the polar region and has been processed into this darker material. Because actually, as you saw on Pluto, most of that stuff that showed up as methane was bright. So methane just by itself is bright. But yeah, so we do have a few little hints about other things on Charon besides water ice.
And you said that these temperatures, it's rock solid, right? This is ice, essentially.
Yep,
right?
The ice basically acts like rock.
Okay.
So my graduate advisor used to say that rock is just the ice of the inner solar system. You can say it the other way around if you want.
That's a nice way of looking at it, of course.
I like it.
Yeah,
So,
so you can.
are we going to talk about the tectonic sash?
That's actually what I was just going to mention.
Good, because
All
it's just screaming at us like.
So I can't claim credit for that clever name, but we called it a sash because you can see it kind of goes from the lower to the upper. It's not directly
Like
around
this,
the
yeah.
equator. And this is this is the same kind of tectonic structures or fault scarps that happens on Earth, on rock. And so these are from the rocks being pulled apart. It's called extensional is the technical word. And so it happens on Earth and it happens on Charon as well. And that's how we get these really large scarps and what look kind of like tilted blocks that you can see in some areas.
Okay, and while we got some of this, while we're talking about the compositions here, I'm looking at Twitter, and Laura Forzik is asking, we see so much water on Pluto. Question for my Pluto peeps, that's you guys. How do we know it's H2O and not OH?
Oh, I assume, so Jason is the guy who does a lot of the chemical identification. I assume it has a OH and H2O have a very different signature.
Right. Yeah. OH is actually not stable as a solid because it will rearrange itself to make water and oxygen, I suppose. But water has a very, like so many other compounds, has a very distinctive pattern of wavelengths that it absorbs in infrared light. And so you can see that pattern in the spectrum of Charon and parts of Pluto. And there's just no way it can be anything else. It just perfectly matches the same signature that you see in the laboratory. And the same goes for those more exotic ices, the methane and the carbon monoxide and so on. We may argue about just how much of them is there on the surface or what the physical configuration is, but the chemical composition, even though we've never touched the surface of Pluto, we are absolutely sure what it's made of because those signatures are so distinct.
Great. Okay. Well, I don't know about you guys, and I'm not an expert, but one of the things that surprised me from this mission was this idea that Pluto had an atmosphere. And I guess I wondered, could you guys talk a little bit about this?
Sure.
Yes.
So Pluto's atmosphere was actually first hypothesized in the early 80s based on the discovery of, I believe, methane on the surface, that they said, oh, well, if there's this kind of methane, it's probably atmospheric. And it was confirmed in 1988 by a group of researchers under Jim Elliott of MIT through a process called stellar occultation, which is one of the ways that we've been consistently studying Pluto's atmosphere from the ground for nearly 30 years now, and hope to continue to do so after the mission. So stellar occultation is, if you have something in the solar system, where it is when you look up at the stars at night, it moves. And so if something passes directly in front of a star, it blocks the star's light. Now, if that object does not have an atmosphere, the light goes out, some diffraction might happen, light comes back. And if you know how fast your solar system object is moving, which we generally do, we can calculate how big it is, especially if multiple people measure it, because some people will see the top blocking off the star, some people might see the bottom, some people might see the middle, and you can put all those timings together and you can get a great shape. However, because Pluto has an atmosphere, instead of the light just going out, the light is actually refracted by the atmosphere. And so, if my hand is the light that we measure from the star, if Pluto comes along, the light just drops down like this, sort of gradually. And how fast the light drops down, you can use to measure the pressure in the atmosphere, and that's actually been seen to change. It actually doubled between 1988, when the first measurement was made, and 2002, when the second and third measurements were made.
Wow, that's really very interesting. I did not know that through stellar occultations, we already had an idea it had an atmosphere. That's great.
Yeah, and we're actually hoping to use stellar occultation to learn more about MU69 before New Horizons flies by there, hopefully this summer.
Okay, good. Okay, well, Kelsey, do you have any comments on do you want to say anything about the atmosphere, Pluto, or?
Sure. It's kind of fun that this is a attempt at an accurate representation of the color as well. And so it's kind of fun that the way that Pluto's atmosphere reflects light gives it a bluish tint to it, which is similar to our atmosphere. And then you can also see the haze layers that I pointed out. There's these thin layers that you see in the blue region.
Mm-hmm. And so this is pretty. What about the density of this atmosphere? Do we have some idea of? We probably do because of the occultations that we were just talking about. But how dense is this atmosphere?
Sure, I can answer that, but
okay.
I'll let John do it.
Okay.
Okay. The pressure at the surface is about 100,000 times less than it is here on the Earth.
So that would be this bright area
here.
Expected
based on the observations from the ground. So it's interesting that such a very thin atmosphere can support all this haze. It looks as hazy as the Earth's atmosphere if you were in, well, maybe not Los Angeles, but somewhere, but, on the Earth, which is quite hazy. So these haze particles are really tiny, and they can be supported even in this very thin atmosphere.
All right. Well, Woad is asking a question that, where'd he go? Oh, here it is. He goes, glad to be back. I was also wondering if names like Cthulhu and Mordor stand a chance to become formal names, or will the AAS, or the IAU, I guess, never approve such names realistically?
We're working on submitting our formal proposal to the IAU, and we hope to include those in the proposal, but we'll see what they say. We're making our case.
Okay, now here is a nice schematic of the Pluto system, which to me looks pretty busy. A lot of this stuff is pretty new, and I know Carol can comment on some of the things because I think Hubble helped with some of these discoveries, but Pluto's actually got a lot going on, doesn't it?
We're not seeing a graphic, or I'm not.
Oh, you're not? You don't see
I'm
it?
seeing it.
Oh, okay.
I see it.
I see it.
Okay, it's just me, huh?
Click on. Can you click on my thumbnail? Does it get? Maybe click on another thumbnail.
Oh, okay, now I've got it.
Okay.
Yeah.
So this is a nice little graphic. I like where you show where New Horizons flew through as it went by. Presumably that's what that plus sign is, and all of this other stuff. So there's a lot of things going on. Now, some of this, Nix and Styx are two moons that I think were discovered by Hubble. Is that right, Carol?
All four were.
All four
Yes.
were.
Mhm.
Okay, I thought
All
these
four of
came
the small
along later.
satellites. Yep.
Yeah, Hubble observed that. Of course, Charon was known for. I actually observed Pluto and Charon a long, long time ago from Canada, France, and actually resolved them with active optical system. But that's another story for a different coffee.
Okay. I want to move on to the KBO target next, but before I do, and before I leave this, is there anything that you guys want me to show that we could talk about? Well, let me just put this up too, because this is a picture of the actual moons. That these some of these are all of these images from New Horizon, or are they from other sources?
All of these images are from New Horizons. Given that our best HST image, which was the best image we'd had of Pluto before the New Horizons flyby, was about 11 pixels across. This is these are all from New Horizons. You need a flyby to get pictures like this. And so the satellites kind of come in pairs. You've got Nix and Hydra, which are about the same size, and then Styx and Kerberos, which were both pretty small. We weren't sure if they were going to be dark, like the dark patches on Pluto, or if they were going to be Charon-like or bright, but they're all really, really bright and all slightly smaller than we expected them to be. We weren't sure if there were going to be more of them. The New Horizons team did an excellent job looking for additional satellites, but it turns out we've got some really talented Hubble Space Telescope observers who found them all.
Great. Okay. Well, so
I just wanted to say about Nix and Hydra that the team that looked at them through Hubble watched again, because all we have from the vantage point of the Earth, where the Hubble Space Telescope is to see brightening and darkening once they were known. And through modeling, they decided that they were elongated. And they actually proposed the way that they were rotating. And it turns out they are elongated. So I thought that was pretty amazing that they had come up with this model, and then New Horizons images those two objects. And in fact, they were elongated. I kind of was shocked that they could tell that from the Hubble data, but they did.
Okay, well, New Horizons is about to enter its next phase, and again, I want to talk about that, but I just want one more question before we leave this, and that is, can you guys comment on what were some of your biggest moments during the flyby itself? What either surprised you or impressed you? Just give me your sense of what you got the most from the Pluto flyby itself. And John, I'll start with you, and then I'll go with Kelsey and then Amanda.
Oh.
What one thing, if you could bring up that would most impressed you or surprised you about this flyby?
Well, I think just the first close-up picture that we got that came down the day after the flyby, just a single image showing spectacular mountains and smooth plains and surfaces that were clearly young and geologically active. Just how your picture of an entire world can change in seconds the first time something like that comes up on your screen. That doesn't happen very often, and it was really amazing.
That's right. In the NFL, they say that's why you play the games. You don't want to just predict. And in science, that's why you go to the planets.
Yeah.
You just no substitute, right? Kelsey, what would you say? What stood out for you when the flyby happened?
Yeah, I mean, it's.
And even now, after you process the data.
Yeah, I think I was, everyone was impressed with how varied the geology on Pluto was. I mean, I don't think anyone thought it'd be quite as different on the different areas as it is. I actually, if you want to see a feature that I'm working on, if you go to slide 21.
Okay, hang on, I'll bring it up.
And this is a feature that is possibly an icy volcano. And
okay, wait a minute.
So
where is it? It's this right here?
Yeah. So
okay, in image A. Okay.
Exactly. Yeah. So just real quick, I'll explain why this image looks the way it is. So the top half is part of Pluto that was directly in sunlight, and then as you move down in the image, you can see it's getting darker, and that's because we're getting to where the terminator, or where the line between night and day is. Yep.
Down here.
And then because Pluto has haze in its atmosphere, there was actually some light that was reflected back down onto the surface, and that was reflected in a way that we could see into the unilluminated part of Pluto. And so that's why we see this possible second feature down in the haze light. But the main feature, informally called right Mons, you can see it's a mound. And then on the right side of this picture, we have the topography. So the reds are high areas and the blues are low areas.
Okay, over here.
And yeah, so then we see two of these things that look like really giant mounds with really big central holes in the middle.
These holes here, this hole A and B?
Correct.
Okay.
Gesundheit. Yeah, so we are not 100% sure what the exact process is that forms these yet, and that's what we're trying to work on. But it's intriguing that they are these really large mounds sitting on the surface, and you can also see that they have kind of a funny texture to them. So these observations are what we're going to try and explain.
How do you get this elevation data?
So
yeah, oh, you go, Amanda.
Okay, so it's through a process, it's like stereo imaging. And so, you know, we took a bunch of different shots of Pluto. So the closer we are to Pluto, you know, our camera has one zoom. So if you have a prime focus camera, no, not prime focus, but I think prime lens on your camera, and you can't zoom. If you want to get up close to something, you have to zoom with your feet. And so as New Horizons got closer and closer, we kept taking pictures of as much as the surface as we could. And when we started getting really close, we could only just do one strip at a time. And when you get closer and you are this close and the angle that you're looking at changes, you can get stereo imaging. You're walking around with a pair of stereo imagers on your face. They're your eyes, and they're the fact that your eyes are, you know, they're far apart from each other. And so your brain is doing that. And so the images from two separate times are sort of put together, and you know the elevation differences sort of pop out in the same way.
Okay, so because of the way that the spacecraft in its orientation with respect to the planet, you could get different angles of the same features and build up a 3D model of the whole thing. Cool. All right. Well, so Amanda, what about you? What was your big takeaway? One of the things that really stood out for you?
So John stole mine you know, it's
the first image, the one with.
Yeah. So just like, you know, Kelsey and I came up with the same slide, you know, I think scientists think alike sometimes, but we got about 4 images down. The day after encounter, we got an image of Sharon, and we got a couple images of Pluto, and I think we got one of the images of the small sats. But the thing that blew my mind is that each image of Pluto we were this, I think, 4x5 mosaic that they were part of, where it's 1, 2, 3, 4, you know, and there was like one here and there was one there, and they were both just completely different, like completely different. Another mind-blowing thing, I guess, image 23, that this is way later in the game, was that Pluto has all this pitting that you can see when you sort of start looking from the other end. That's just wild, in my opinion.
Yeah, right here. Yeah, so I see what you mean. These pits here.
Yeah.
Here. Yeah. Awesome. Yeah, that is. So these are icy plains that are. It doesn't really show where on Pluto this is, but yeah, I can see what you mean. There's lots of weird stuff here. I want to go back to this one too. This one is. Look at this. This was an image.
Oh yes.
This is our favorite, I think.
Yeah. Well, okay. Describe this thing. This looks amazing. What are we looking at here? Go ahead. Well, go ahead, John, since you started
Kelsey.
first. Or Kelsey, whomever.
Okay. Okay, here's Pluto. And as we're flying past, we're taking pictures on the way in and taking pictures, as Amanda said, from different angles. And then we took some looking back as well. And so now the sun is on this side of Pluto, or behind you in that picture, behind Pluto in that picture. And so we're just
both
seeing
your little hand gestures and the image in, so I'm going back and forth.
Yeah, yeah. And so this is a crescent of Pluto, seen from as we're flying, you know, behind. And it's just got a really cool view, actually, of some spiky mountain blocks. And that smoother area is the tip of the heart. And that's actually where some of those pits that we just looked at are seen.
Wow, look at this. And there's a 30-kilometer bar for scale. I mean, these things are huge. Look at this thing. I mean, these are really large. Just
They are.
amazing. Well, that brings me to my segue,
And
because I'm running out of time. We're
The
leaving.
atmosphere was great.
That's
Yeah.
true.
It
You
was
could
great,
see
too.
the haze
Oh, it was
layers there as
fantastic.
well.
True.
The haze was
That's one of the most impressive pictures. So, by the way, well, I'll ask Kelsey if I can post these somewhere later, but I'll do that in a minute. But before I do that, so now we've flew by Pluto, and there's the whole mission was designed to be in basically 2 phases, right, John?
Right. We designed the space.
But it wasn't, before you comment on it, it
Yeah.
wasn't clear that the second phase was going to happen after the flyby, right? So let's talk about after the flyby was going to perhaps go and see a Kuiper Belt object, which you alluded to, and that was approved, correct?
That's right. The Kuiper Belt is this huge swarm of objects that Pluto is part of, but Pluto's near the inner part. So beyond Pluto, there are hundreds of thousands of other small objects, mostly much smaller than Pluto. And we wanted to go see what those were like up close. But there was a big question mark for a long time, because we didn't know if any of them were actually along the path of our spacecraft close enough to us to reach. So we spent a lot of time as we were approaching Pluto, searching the skies with telescopes on the Earth and the Hubble telescope, looking for an object that we could fly by. And we found one in 2014, the year before the flyby. And just after the Pluto flyby, we fired our engines on the spacecraft to set a course towards this one object that's only probably 20 miles across or so, and that we will now reach on New Year's Day 2019.
2019.
Yes. And we had to get approval from NASA to fly this mission for them to fund us to do it. And we have that approval now. So we're full steam ahead into the Kuiper Belt to explore this new world.
Okay, and and as far as the instrumentation and stuff on board, has that been put into any kind of safe mode, or is it all still operational? Do you do anything while you go from like it took a long time to get to Pluto, 9 years, almost 9 years.
So throughout the encounter, we put the spacecraft in and out of hibernation, which was a partial shutdown of a lot of things, and it prevented the electronics and all that stuff from aging, if you will. And so since the encounter, the spacecraft has been awake, and it's going to go back into hibernation, I think fairly soon, for about 7 months. But it's not going to be doing a lot of hibernating, because it's actually going to pop out of hibernation. In our search for MU69, we found a lot of other Kuiper Belt objects that New Horizons can't get close enough to. And so, but as you saw that very unique view from the back of Pluto, we can learn a lot about an object, even looking at it from a side that you can't see from Earth. And so we're going to be taking the spacecraft out of hibernation a couple times and just looking at various other Kuiper Belt objects. We've got a list of about a dozen or so, many of which were discovered as part of looking for MU69 that we want to learn more about.
Okay. How far away is it again? How far out is this Kuiper Belt object?
About 44 astronomical units, where 1 astronomical unit is in our sun distance.
So 44 AU.
Right. So on Pluto, when we flew back, was about 33 astronomical units. So 11 astronomical units, about 1 billion miles beyond Pluto.
Okay. And how far will New Horizons get to? Did you say MU69? Is that right?
Yeah, 2014 MU69.
We're working on a better name.
Yeah, I hope so. Thank you. Thank you.
Yeah, the name is it's a provisional designation, and so if you see the number, it is 2014 because that was the year it was discovered. M refers to the fact that it was discovered in the first seen in the last week of June, and then U69 is gone through the alphabet 69 and times plus about 20.
Okay. All right. Well, and so how close will it get, roughly? 3,000
kilometers.
Wow, really? That's...
Yeah, well, we choose the flyby distance. We choose the flyby distance.
That's our current nominal plan. Now, we haven't done all the detailed planning yet, and we may decide when we do that maybe we have to be a little bit further, or maybe we can get a little bit closer, but we like to fly by about that distance.
How fast is it going?
About 10 miles a second.
Wow. So this is a bit of a thread the needle kind of thing, right? I mean,
oh yeah.
You want to get... All right, we've got a lot of questions. I want to get to some of them here. Kepler 1609 is asking, is Pluto geologically active? That's a good question. You in the Charon picture, you had a tectonic belt.
Mhm.
Is
Kelsey?
Kelsey?
Yeah, so actually some of the other features that we looked at, like the nitrogen ice sheaths, that it can actually flow like glaciers, that Amanda talked about. And actually, if you want to show real quick a picture of what we think could be some of that flow, you can go to the final slide, which is 38. And that kind of gives you an idea of what we think is probably a nitrogen ice glacier on Pluto. So we have that kind of activity. And then we also have the...
Wait, whoa. This is a glacier moving around? Okay.
We think this is a nitrogen ice glacier moving off of the right side, which is a little bit higher, down into the left side, which is part of that Sputnik Planitia area.
Oh yeah, so it would be like spreading out. Is that what the blue arrows are indicating?
Yeah, so it's coming down off the red arrows in the highland and then moving down into the lowland, and it could be multiple flows that come out here. And,
okay.
Wow.
Yeah, so
All right.
there's that kind of activity, and then there's also the image we already saw before of what we think might be an icy volcano.
Okay,
And
great.
that could be a different kind of activity.
All right, so there is some activity going on there. Good. Okay, so let's see. Is a couple more questions. I'm running out of time. George Caldwell. Hello, George. Is Pluto's atmosphere appreciable? Wouldn't the gases condense under the low temperatures?
Well,
so Eris, which is a lot further out, is very shiny, and
Eris is another minor planet.
Yep, Eris is another planet. It's very shiny, very bright, and based on stellar occultations, does not have an atmosphere. And so one of the big questions about Pluto's atmosphere, and people are going back and forth on this one, based on the changes in the measurements we do see, is that when Pluto gets further from the sun, it could be cold enough to collapse, but we don't know 100% the answer. You know, wait 100 years and we'll find out. But there's predictions that it could go either way. And I think currently our colleague Leslie Young and Kathy Olkin work on this, and based on their recent measurements, they do not believe it will collapse, but it could theoretically.
Okay, so we're running out of time. We got a couple of minutes left. I just want to say that this slide was included by Kelsey. Is this on your cars?
I don't own a car.
It's on my car.
I like
it's in my car.
My other vehicle explored Pluto. So do you put it over the old license plate or over the old bumper sticker, or do you have it underneath?
I have it just tastefully overlapping on one side.
Yeah, different people did different things.
Awesome. Well, that's
great.
Yeah, so this is I don't know. This is the mission that just keeps on giving. Pluto we've learned so much about this minor planet since it flew by. One of the things that I'm hoping we guys can do is as 2019 approaches, maybe you guys might come back and give us some more insight into the KBO 2014 MU69.
Sure.
Oh, yeah, awesome. All right. Okay, well, thank you very much. I want to thank all of you guys for taking time out to share with us some of the latest discoveries from NASA's New Horizon mission. I want to thank my guests, Dr. John Spencer, Dr. Kelsey Singer, and Dr. Amanda Singari, all from the Southwest Research Institute. Are you all in Boulder? I know you're out of town right now, Kelsey, but you're all in Boulder?
Yep.
Yeah, John's like 30 feet from me down the hall.
Great.
And normally I'm like, much closer than that. Yeah.
Yeah, so, all right. Well, I want to thank all of you for taking time out. Kelsey, I'll ask you offline about the possibility of maybe having some of these visuals made available. Well, if possible, I will make sure the link is on the website so you guys can download it as well.
Yeah, I was going to say, actually, almost all of these are taken from the Johns Hopkins University Applied Physics Lab, or JHU APL website, and I put that in my my lower third bar here, but it's just pluto.jhuapl.edu, and it's really easy to Google if you just Google New Horizons and Pluto.
All right, and I'll also put that out on the website as well, so you guys can download it. Thank you, Kelsey, for making those available. Some awesome stuff. So, all right, folks. Nice. Well, Carol. Carol, I guess we are done with this one. We have some pretty cool stuff coming up down the pike, don't we?
Yes. You would ask me that. I know that next week should be a footsteps to Mars.
Right.
And
we're going to be talking about the water on Mars and whether it was a water world in the past.
Right. And then cooking up something for November 10th. And then we're actually not going to have an astronomy coffee on Thanksgiving. Everybody should have their own coffee.
That's right. So stay tuned. The best way to find out about where these Hangouts are happening, folks, is to go to deepastronomy.com, hit the subscribe to our newsletter. I'm going to start every Monday. I'll be sending out notices on what the Hangout is and where it is. You can also follow me on Twitter. That's also a good way to get it at Deep Astronomy. I make sure everything is posted there as well. So on behalf of our guests, I want to thank everybody for taking time out to share with us from the latest research and images from the NASA's New Horizons mission. And we hope you guys will join us next week. And thank you all very much for watching. And as always, keep looking up.
Keep looking up.
Bye.
Thank you.